Wall Street spends billions of dollars and hires the world's smartest mathematicians to predict the market.
That's my quant. Let's look at him.
With an online data science course completed and the help of the world's least reliable expert, I decided to build a machine learning model to predict the price of frozen concentrated orange juice futures. I'm betting my own real money on the results. If you enjoy contributing to Wall Street's champagne fund via out of the money, 0 days to expiry calls, then you're probably familiar with the cult classic film Trading Places. The plot basically boils down to two guys stealing a secret US Department of Agriculture crop report to front-run the frozen concentrated orange juice market and bankrupt a pair of evil billionaires.
Margin call, gentlemen.
A classic film, and it of course cemented frozen concentrated orange juice into the Hall of Fame of trading memes. Just don't ask about the train scene. For the sake of simplicity, I'll just say OJ going forwards. Now, I assumed the market might work similar to a prediction market where traders make bets and then the market settles on a resolution, in this case a price at harvest, when everyone finds out how many oranges have grown that year. Of course it's not like that. Oranges are grown all over the world and production is estimated constantly based on weather, disease and many other factors. So it ends up looking like this, with about 2 billion tons and $8 billion worth being traded every year. I start wading into the data, and within a few days it's 2 AM and I'm accidentally reading wind speeds from 1851 hurricane data. Because of my inexperience and reliance on ChatGPT, which would soon be advising me to add things that better advises removing,
It's fooled me once. Shame on you. It fooled me, we can't get fooled again.
I decided I'm just going to create a simple classification model. These are basically mathematical yes or no machines. You train them on past data where you already know the answer, in my case whether the price of OJ went up or down 30 days later. The model uses very complicated maths that we fortunately don't have to understand to look for patterns linking the inputs, things like recent prices, weather, crop yields, to that target. When you feed the model the historical data, it is split into two. Most of it, the training data, is where the model can see the target to learn from it. A smaller portion, the test data, is hidden, and here the model uses what it's learned to make predictions so you can see how well it's working. After it has done all of this, you then have a working model. You can give it today's data and it will make a guess, along with how confident it is. What could possibly go wrong? So I started with the obvious, OJ price history. I downloaded the daily price volume data for every day since 2002. I then added some simple calculations like moving averages, variance, and whether the price has been going up or down recently. I then set up an extreme gradient boosting or XGB classification model. Fortunately, people with PhDs in statistics have figured this out, so all people like me need to do is literally this, which feels a little bit like bird watching with the Hubble Space Telescope. It does take a bit more code to give the model my data, tell it what the inputs are and the target is, divide it into training and test data, and then get it to return the model's accuracy. But I've done all that in the background, so let's press go and see what happens.
Crunch those numbers. Crunch.
So this tells us the model has an accuracy of 0.44. An accuracy of 0.5 would be the same as flipping a coin, so this isn't good. Somehow it's worse than random. Let's add data that should have more predictive power, weather. Specifically, the weather of the USA's orange capital, Florida. To keep things fairly simple, I chose one location, everyone's favorite place. That's right, Legoland. There are a few online weather-based sources, but I've used OpenMeteo, definitely for more reasons than ChatGPT told me to. I also add some calculations such as the max, mean and min temperatures and total rainfall for the last 30 days. This is to try and capture frosts, heat waves and droughts. So let's see how that goes. And somehow that's even worse. However, when it comes to Florida's weather, there's a bit of an elephant in the room. Hurricanes. Now, Al Gore told me hurricanes are bad and they're going to get worse, so let's add them to the model. When I first downloaded the data from NCIE, I just merged the data into my main table, not realizing the data went all the way back to 1851. I can only guess hurricane weather reports from then were just an old man flying a kite and writing down how difficult it was to hold on. I also did some Googling, and it turns out Florida isn't the big swinger it once was in global orange production. its main exports now are news stories with alligators and GTA trailers. So I add a few weather locations from Brazil and the El Nino number from NOAA. I'm not really sure what it's measuring, but hopefully it means something. It would make sense for future prices to be influenced by recent yields, so I added the previous year's orange production totals for the USA and Brazil. To capture input costs such as transport and fertilizers, I added oil price data, and I added sugar price data with the logic that if oranges are expensive, they will just be replaced with sugar and artificial flavorings. So let's add all that and see what happens.
Crunch those numbers again.
0.49. So basically a coin flip. So it's not going well. Now, you might be thinking that weather data from the day it happened shouldn't be able to predict future prices, because the thing about weather is, it's not exactly a massive surprise. So won't it already have been priced in for a week or two? Yes, probably. But historical weather forecast data is mostly locked behind paywalls, and what's the point of a more accurate prediction model if you have no money left to use it? So instead of doing the smart thing, I'm just going to throw more computer power at it. The dataset I have now is actually still fairly small. 1 row a day for the last 20 years is only about 6,000 rows. So we can try and add a more demanding machine learning model. And I'm going to try adding a grid search. When you set up an XGB model, it has parameters that determine how it will behave. I usually just leave these on default so I don't understand them. But by adding a grid search, we can get the model to test all the different combinations of these parameters to see if it will create a better model.
Crunch those numbers again.
And okay, the accuracy number didn't change much, but I've also added some other ways to measure the model's performance. And the AUC here, or area under the curve, actually suggests the model could be working. I know it's hard to believe, but I now potentially have a useful model. ChatGPT even says so. When the model predicts the target, it also attaches a score of the confidence it has in that prediction. And when the AUC evaluates the model, it takes into account these confidence scores. So what this probably means is that sometimes the model isn't really sure if the price will go up or down, but has to throw out a guess. But when it is sure, it might actually be making good predictions. To get a better understanding of the model's accuracy, I used a confusion matrix. This compares the true target with the model's predictions. So when the price actually goes down, the model predicts the price will go up 63.5% of the time, and when the model actually goes up, the model predicts the price will go up 64.15% of the time. So essentially the model is predicting stonks always go up. So let's see if we can get the model to only make a prediction if it's confident, and we can do this by tuning a parameter known as best T. We can try all the best T options we like, but how do we know which is, well, the best? Of course, ultimately, only one thing matters now. If I had traded OJ futures based on the model's prediction for the last 20 years, would I have made money? So I coded a quick backtest where as soon as the model predicts up, I buy and hold for 30 days and then sell, and then wait for the next buy signal. And it turns out if I did this for the last 20 years, I would have made a negative 13% return. So not great. Now, every day the model is trying to predict if the price will go up in 30 days, but if it's not predicting up, then it's predicting down. So what would happen if I short the market when it's predicting down? However, this is dangerous because if you buy something which goes to zero, the most you can lose is 100%, no matter what anyone tells you. But with shorting, the potential for losses is technically infinite. In fact, you will owe more money than you started with if the price at least doubles. And OJ prices more than quadrupled between 2021 and 2024. And when I tried that, the model was profitable, with a whopping 5.6% return in the last 20 years. So now let's try changing the best T used in the backtest. Best T is set to 0.5 by default, so the model will buy if it's over and short if it's under. To ignore the low confident guesses, I set the model to buy when best T is above 0.6 and short when below 0.4. And that has 4 times profits to over 20% of the last 20 years, which is only slightly dampened by the S&P 500 increasing by around 600% in the same period. But now I wanted to see these trades on a graph to see when they were triggered, and that's when I realized the backtest wasn't doing what I thought it was at all. It was only testing on the test data, of course. So when I set up the model, I started the data from the 1st of January 2002 and allowed the model to see the target for the following 720 days, making it training data. I then covered the target for the next 30 and allowed the model to make its predictions, making it test data. It then repeats this until it gets to the end of the data. But this meant that when I backtested its predictions, I could only use the ones it made on the test data, which was only a very small portion. So the backtest only made about 10 trades in the last 20 years. So I added a line of code, which means the model now starts on day 1, trains on the first 720 days, then tests on the next 30, but now instead of going on to the next day, it goes back to day 30 and trains on the next 720 days. So every bit of data is now used for training many times over, but in a slightly different bundle of data. More importantly, every bit of data is now tested on at some stage. But after waiting for 15 minutes, this is what I get. Look at that. The model would have made 433% return over the last 20 years. And if I try every combination of best T, I get 0.59 for buy and 0.2 for sell. And this returns almost 600%. This would have turned 10 grand into almost 70. It seems too good to be true. And to be honest, it probably is. Somewhere it's likely I've introduced leakage. This is when the model can see data it shouldn't at the time of prediction. So for example, if it's getting the max temperature of the day and giving a buy prediction, a trader wouldn't be able to make this trade because by the time they have the day's max temperature, market is closed. And by the time the market opens the next day, the price will likely have moved. I have tried to eliminate this by shifting out most data by the appropriate amount, but it's likely I've missed something. But after all that effort, I can't just leave it there. Today is the 8th of June 2026 and the model has been screaming buy for the last 7 trading days. So I took the leap of faith. My broker of course ripped my eyes out with the spread, but I am now the proud owner of £230 or about $300 of orange juice leveraged 10 to 1. This works out to a contract for £3,750 or about 1.7 metric tons of frozen concentrated orange juice, which I will sell in 30 days. I'm not waiting to see what happens. Instead, I'm uploading it now. That way I can't cheat and pretend it worked. So, if you want to support the channel, please go out and buy as many oranges as you can.